All right, example 6. Solve by using a graphing calculator. So a package of supplies is tossed from a helicopter at an altitude of 200 feet. So helicopter and stuff's tossed from it, 200 feet in the air. The package height above the ground is modeled by h of t equals negative 16 t squared plus 28 t plus 200, where t is the time in seconds after it's tossed. How long will it take for the package to hit the ground? So, let me write that a little bit more clearly. We're trying to find when the height is 0, because that's when the package reaches the ground. So the height is 0 equals negative t squared plus 28t plus 200. Now, one thing about this graph, it's a negative a value for the squared, so I know it's going to be a quadratic that opens down. It's 16, so it's going to be very, very steep. And the y-intercept is at 200, right? So I can tell all of that just by looking at negative 16 there and 200 there. Now, if you are in physics, you probably know where the negative 16 comes from and what the 28 means, but we don't really need to know that for this class. There is a reason why those numbers are there, though. But taking a look at this, I can make a couple predictions about the graph. One, it's very tall. Uh, Two, and more importantly, there's going to be a negative root and a positive root. Let's think about what those things mean. A negative root would be negative time. So before it's dropped, it hit the ground. That doesn't make sense. There's no, like, in this universe or in reality, this model only works after it's dropped. So there is no time before it is dropped. So there's going to be a solution that we get, the negative root, and it's not going to make sense. Makes no sense. Over here, positive root, that's the one we're looking for. It makes sense. And if we think about it, if we're dropping something from 200 feet, is it going to be in the air for a minute? Is it going to be in the air for 2 seconds? Right? You can kind of get a feel for it. I mean, you've probably dropped stuff off of a tall deck before, or saw something fall from a roof once or a tree. It takes a couple seconds for it to fall down. So there'll be a few seconds here, but it's not going to be in the air for like 5 minutes or anything like that. So my bet is that there's probably uh, 1 to 10 seconds is probably a reasonable answer. But how do we figure this out? Well, we just go to our NumWorks and we go to the functions, click OK. We edit our function here and we type it in, negative 16 x squared plus 28x plus 200. Click OK. And we're going to plot the graph. You can see you're like, oh man, that's not very steep, Mr. Willig. But think about this. It only goes out to a little bit more than 4 seconds, and that's about the same distance as 200 feet up is. So imagine if this was actually scaled in a 200 by 200 screen. It'd be very, very tight on it, right? But we want our roots, so we go ahead and click the OK button. Calculate, click OK, and go to zeros. We don't want the negative one, we want the positive one. So we get, it says x, but for us we know it's going to be t for time equals 4.5172. It doesn't tell us where to round it to, so we just say like 4.52. That's pretty good. 4.52 seconds. All right. Now you could do other cool things with that calculation. Click OK, calculate maximum, and there we go. There's the maximum x coordinate of 0.875 and 212.25. So they didn't just drop it straight out of the helicopter, or they dropped it out of the helicopter, but since they were standing it a little bit above, they'd like toss it out of the air or something. I don't know what's going on here. Interesting problem. But anyways, We did all of that work on the calculator. So what do I show on my screens so I can demonstrate understanding of the problem? Because between writing that the function is supposed to equal 0 and writing this, t equals 4.5172, everything was done on the calculator. How do I show knowledge of what was going on? First thing that helps, drawing a picture. If you can show me that you were thinking about it and you predicted something about the roots, like which one you wanted before you got in, that's usually pretty good for showing your work. Another thing to do is, instead of just writing 4.52 seconds, what you want to write instead is a complete sentence. And the way you want to do that is you take the question, how long will it take for the package to reach the ground? And you turn that into a sentence. It will take 4.52 seconds for the package to hit the ground. Now, what this does is this shows me that you understand it's more than just some number that the calculator gave you. There's some context to the problem, and that can demonstrate understanding of it. You could also, if you wanted to, if you were not sure, you could also just say used NumWorks, calculated zeros. Because if you can tell me which functions you were using on the calculator, that's also telling me you know what you're doing because you told me the right buttons to press. Now, if you gave me 0.52 seconds and you said NumWorks calculated maximum, I'd be like, this person doesn't know what they're doing, because this is not a maximum. This is a root, and those are two completely different things. So there's a couple different ways to show your understanding, even if you're not actually writing anything down on the paper. The calculator is still a skill, so practice it.